I think the first one, a good starting point or entry point into this discussion is just talking about what makes deployment of traditional software systems so different from deployment of machine learning systems. So let's go to Jacques on this.
I think that's a very interesting question, and is in a way why so many teams do struggle with deploying models to production. I think maybe the first thing to note is it is very different, but it also comes from the same place. To deploy your models to production, you need a software engineering team. Like you need an engineering team to be able to successfully deploy your models, especially when you start having some of these really tough requirements around latency, how quickly your models can make predictions, or scalability. You will need an engineering team. However, that engineering team will need to be specialized or specialize themselves over time as they get more experience, but they will need to specialize in deploying ML models because there's a number of requirements and differences with traditional software. And when I was thinking about it, I think two came to mind. And the first one was really around the requirements. So machine learning models by design are very data heavy. You need to collect a lot of data. You need to pre-process or format that data in the right way to then feed it to your machine learning model that can then make a prediction. And it needs to do that very quickly in most cases. Like when we're talking about fraud detection, for example, you need to look at the past payment history of a person or a credit card, aggregate all of that data, make a prediction, and then return that prediction in 10, 20 milliseconds. And that's a really tough engineering challenge. And that requires infrastructures and tools that are very different from what you would use for traditional software, because you need to be able to query data very quickly. You need to be able to transform that data very quickly. And I think that's one of the things that makes it different from the traditional soft kind of systems in general, is those two data heavy versus low latency requirements. And then I think that the second part of it, and we'll start talking about it when we go through some of the kind of next questions, but I think the biggest challenge is that even if you successfully deploy your model, if you feed it wrong data, it will still work in a sense. It's still going to return a prediction. It's just going to return something, a completely wrong prediction. And so you just don't have as many errors or bugs as you would have in traditional software systems. If you're building a dashboard and all of a sudden a database doesn't work for some reason, you're going to get errors, you're going to get bugs, you're going to get higher latency, and you're going to see all of these things in your monitoring tools. You know something's gone wrong. For ML models, most often what will happen is all of that data will still go through the system, still make a prediction, but actually the system is in a broken state, but you just don't know about it. And that brings a lot of additional challenges that make it very different from traditional system. So requirements and error tracking, I think, are the two things that make it different from software systems in general.